All right, on this first problem, we're finding this missing value of k. So we've got this system that's given. In the system, the first equation is negative 5y plus kx equals 4. The second equation is 2y minus 9x equals 11. So if we're going to try to find k so that the lines are parallel, when we talk parallel, we're talking about lines that have the same slope, right? So the two equations, the way they're given, it's not quite standard form the way they're given, right? If you wanted to rearrange things, you could. Like if I'm real technical about this, the standard form for the first equation would be kx minus 5y equals 4. And standard form for the second equation would be negative 9x plus 2y equals 11. And even then, I'd have to tweak that second equation a little bit more to make it officially standard form, because this lead coefficient is negative. But rearranging things and going back here to the idea that I can find the slope of a line in standard form right here by taking my x coefficient, or the opposite of that x coefficient since that's negative, and placing that over my y coefficient. Let's come back and use that here. If I take k here, my x coefficient, make that negative, put that over the y coefficient, negative 5, I could set that equal to, take the x coefficient from this equation, change the sign, right, make that 9, and place that over the y coefficient of 2. I could set up a little proportion now, based on what I know about the slopes in that standard form. And from that proportion now, I could cross multiply to solve for k. As I cross multiply solving for k, I'm going to have negative k times 2, or negative 2k, equal to negative 5 times 9, negative 45, divide by negative 2, negative divided by negative positive, we get 45 over 2. There's that missing value of k. All right, we're given three ordered pairs. We're asked to find k. And the understanding is that these three ordered pairs are supposed to fall on the same line. In order for this to be true, basically what we want to do here is we want to sync up their slopes. So I'm going to take these two ordered pairs here. I'm going to try to find the slope between those 2 points. So if I subtract from second point to first, I've got 4 minus 2 for the y's. Staying consistent here, going second point to first with the x's, it'd be k minus this entire quantity here of k minus 1. So I do have to be careful. Need some parentheses there. Need to understand that negative is going to carry through. Now, in order to solve for k, I need to set that equal to something. So what I'm going to do is I'm going to set that equal to. Now let's explore the slope here for the last 2 points. Or if you wanted to, take this third point, compare back to this first point. Doesn't matter. But if I compare the second and the third, difference in the y's going from this third point back to the second, it'd be 11 minus 4, over difference in the x's, it'd be 3 minus k. All right, let's see what we have to work with now. If we clean this up a little bit, we've got 2 over, carrying that negative through. Looks like the k's cancel out, right? As the k's cancel out, we are left with a 1. That's all going to equal, we've got 7 over here, over 3 minus k. I've got my proportion. I do a little cross multiplying. As I cross multiply, I appreciate on this diagonal here that this 2 is being multiplied to the quantity of 3 minus k. And I'm setting that equal to the product I get on the other diagonal, which is 1 times 7, or just 7. Got my equation set up to solve. Distribute. 6 minus 2k equals 7. Subtract 6 over, negative 2k equals 1. Divide by negative 2. We find our missing value of k to be negative 1/2. All right, if we've got a line that's going through the point 2, 1, has a y-intercept of b, let's think about the ordered pair here for b. Or, I'm sorry, for the y-intercept rather. The y-intercept being b, that ordered pair would be 0b, right? So right now what we have working for us, we've got one point, we've got a second point, and we're supposed to express the x-intercept k of the line in terms of b. So if we established a third point from our x-intercept, that would have to be, if the x-intercept is k, an ordered pair of k0, right? That's what all this means. So once we decipher that information and we think back to what we just did on the previous problem, we've got 3 points to play with. We want them all to be on the same line. We can do that little slope formula trick again. If I compare my first 2 points here, well, subtracting from second point to the first, I'd have b minus 1. That's my y's, right? And I'd have 0 minus 2. That's my x's. I'm going to set that equal to, now that I've compared the first 2 points, I'm going to compare the last 2 points. So going from this third one back to the second one, take 0 minus b. That'd be the difference in my y's over. Difference in the x's would be k minus 0. So we've got all these variables floating around. Trying to understand the question here, we're expressing the x-intercept k of the line in terms of b. So are we solving for k or are we solving for b? We're expressing the x-intercept of k, right? In terms of b. So we're solving for k. If we solve for k, if I clean this up just a little bit, I've got b minus 1 over negative 2. That equals, this would be negative b over k. Right? Solving for k, I could cross multiply. When I cross multiply on this first diagonal, I've got a quantity of b minus 1 multiplied to that k. So I'm careful how I group things. I'm going to set that equal to negative 2 times negative b, which is positive 2b. Now, do I want to distribute that k through? Usually I do, right? Does that make sense here? Doesn't make sense here. You're solving for k. So whatever's attached to k, this b minus 1, you want to divide that over the other side. So divide both sides by b minus 1. This b minus 1 goes away. You've got 2b over b minus 1. So there is your x-intercept k in terms of b. All right, if these are in direct variation of each other, and we know that y varies directly as x, we've got 2 ordered pairs to consider trying to solve for a. What we're going to do is simply take each ordered pair and we're going to set up this ratio right here, y to x. So first ordered pair, I'm going to take negative 4, I'm going to put that over the 3/2. I'm going to set that equal to, from the second ordered pair, take y, which is a that I'm looking for, put that over the x value, which is negative 6. That's all this means. Once I set that up, got my proportion again, cross multiply. Got negative 4 times negative 6, which is 24. That's going to equal 3/2 times a. Got some options here as far as how you want to proceed. But if I'm solving for a, maybe multiply both sides by 2 to clear the fraction. If you multiply both sides by 2, you got 48 equals, cleared the fraction now, so it's 3a. Divide both sides by 3, and a is going to be 16.